Please join me in welcoming Colin Fay, who's going to talk about prod is not a four-letter word.
Okay, so hello everyone. Thanks for the introduction. So I'm not going to introduce myself again, but who I am, I'm Colin Fay. So I'm coming from France, as you might hear from my accent. Here is my Twitter handle if you want to complain about what I am going to say, or if you want to send some kind words, that's good too. So I work in a company which is called ThinkR. So what do we do at ThinkR? We do R engineering and data science engineering. We also do training and consulting. And one of the big things we do is provide to the company tools and applications so that they can use R in production. That means that we are empowering them to use R inside production, so inside a reliable environment and with reliable tools. So with R and data science engineering, that includes building packages that are going to be used by the data science team, but also mean making the gap between the people inside the data science teams and the people inside other teams in the company. For example, if you have a team of data scientists that are building models that are going to be used by, people from the marketing that might not know how to code, that maybe they're not confident with using R, opening a terminal, or even opening RStudio and coding. They just want tools that they can use in production just to have insight about their data. So this is also something that we do. So we bridge the gap. We do the bridge between the data science team and the IT team, and providing tools for R in production. So I'm here today with this talk called "Prod is not a four-letter word," and giving you some advice about how to send R into production. Okay, so first of all, what are we going to talk about today? So first of all, I'm going to introduce with what does the word production even mean? Because, we give a lot of talk and we talk a lot about sending R to production, using R into production, but what does that even mean? From someone coming from a more academic or statistical background, what does production mean? What do we mean when we say we're sending R to production? Then I'm going to talk a little bit about R in production and the tools that exist to help you send R to production. And finally, what are the big challenges of sending R into production? So before starting, is this something that you have ever heard? So who have ever heard? That's good that we have this prototype in R. Now let's rewrite this with a production language. Who has heard this before? Okay, so that's actually something pretty common that we hear when we are when we are developing tools and softwares in R. And I think this is something that we've heard this so much, but that we have started to convince ourselves that this is something that is true. That we are building proof of concepts in R, but at some point we are going to have to rewrite our proof of concept with a production language. But when I hear that, I like to answer with this quote from a good blog post that Gordon Shotwell wrote, that says that all programming languages are just a bundle of trade-off, and no single language is going to be globally superior to another. And the thing is important with this quote, I guess, is that there really are no production language, only production engineers. What that means is that if you are confident and if you are good with R, you are going to build good software and good tools. But if you are good with R and you don't know Python, or you don't know, JavaScript, or Node.js, or Java, you are probably going to write bad softwares with R, with Java, or with another language. I'm good with R, I know R, and I can build reliable softwares with R, so excuse my French, but I'm going to build shitty tools in Java, because I don't know Java, right? So The idea is that R is not a language that has been designed primarily for building software for production. But if you are good production engineers, and I'm going to show how we have all the tools to build like production softwares, you can be good production engineers with R. Also, when I hear that R is not good for production, I like to do some name dropping, because it's always good to quote some people from the Silicon Valley, So these are some companies that use R in production. And I'm like, if R is not good for production, why is Facebook using R in production? Why is Mozilla? Why is Airbnb? Why is Uber using R into production? And I'm not just doing name dropping. I'm not like inventing these names. So if you want like proofs, you can go to this link. So this is an open repo we maintain that have a list of articles and packages that are actually built by this company. So if you go to the Facebook part, you're going to have articles written by the people from Facebook about how they use R in production. Same goes for the other companies that are on this slide and other companies. So there are actual examples of big tech companies that are using R in production. So if R is not good for production, why are they doing it, right? I think people from Facebook, they know what they are doing. So I guess if they are using R, it's because they trust the language. So first thing, if ever someone tells you R is not good for production, just answer them that this is not true. So what is production? So I've chosen this image because most of the time when we are talking about production, like you are thinking about big rows of servers with wires everywhere and, a guy in the back with a big beard and it's like, so this is basically the idea that people have about production, but actually this is like something that's been running in the software engineering community, but running things in production is not just these kind of things. So as I was preparing this talk, so 3 years ago or 4 days ago, I stumbled upon this tweet. So it concerns machine learning, but the question is, what do you mean by being in production, and what qualifies something to be production ready? John here says that a lot of people are using this word, and it means different things depending on in which domain you are working in. And I'm going to use some of the answers to this tweet because I found some interesting answers there. Also, these are some quotes from people from the R community about what does production mean. So Mark Sellers says that production is anything that is run repeatedly and is relied upon. Very important, this concept of something that is relied upon. And also a quote from Joe Cheng. So Joe Cheng works at our studio, is the person who created Shiny. And something important from this quote also is use and rely by real user with real consequences if things go wrong. So this is an answer to the tweet from before. So the content itself is not that important to be talked about, but I think that something that is very interesting about these answers is that it focuses on two things that are important when you think about production. Is that it does not only impact the users. So when you are talking about something for production, something production ready, it's not only the people who are using the software, who are using the package you are building. It's also the persons who are building the software who are building the application. So the engineers that are behind this piece of software. So very important to remember that something that is in production is something that has impact, real life impact, and is relied upon by the person and the users, the persons who are using your software, who are using your application, and the person who have been engineering your the software. So there are these two sides of production. There are the engineers and there are the users. And both of these groups rely on the piece of software and on the code base. And the consequences, if something goes wrong, is for the users and for the engineers. So first of all, something that is in production. So first thing, of course, it is used. Like this tweet also, if nobody's using it, it's not in production. Of course, I'm not gonna talk about this a lot, but if nobody is using your product, it's not something that is in production. And something that is in production, so a piece of software that we can say is in production, is something that is relied upon. That is to say that people put their trust inside the piece of software that has been built. So, an answer to the tweet also, if turning off breaks your business, it's in production, of course. So the users, they trust the software. They trust the software to be first available. They trust the software to make decisions, and they trust the software to help them do their daily job. For example, if you think about a production application, small one called Facebook. I don't know who's heard of Facebook, you know. So something like Facebook, so there are people that are just users of Facebook, but there are also people that are building their business on Facebook pages. So they are using Facebook on a daily basis to do their job. So maybe, I don't know, it's a local restaurant that uses Facebook as a platform to communicate with their visitors. And so they have a whole admin backend they can use to publish content and to communicate with their community. So first of all, Facebook pages can be considered in production, of course, because when you have a small business that relies on Facebook pages, you expect Facebook to be always available. So when you connect to Facebook, you expect it to be available. You also trust it to make decisions. Because when you are running a Facebook page, what you've got is insight about how your communication performs. So what are the pictures that people like? I don't know, if you are using Facebook event, you are using metrics that are provided by Facebook itself to make decisions for your business. And of course, you trust the software to help you do your daily job, because if, I don't know, every morning you are publishing the daily menu on the Facebook page, you trust Facebook page to be there to help you do your daily job. On the other side, the developer who built Facebook pages and Facebook itself, they also trust the software. So they trust the software first to keep running. That is to say that it's linked to the software being always available for the user, so they expect the software to keep running. They trust the software to be bug-free. Spoiler alert, that never happens. No software in production is bug-free. So sending to production is also making peace with yourself about sending bugs to production, because bug-free software don't exist. Also, they trust the software to be customizable. That is to say that that's not the case with Facebook, but with a piece of software like a Shiny app, you expect it to be customizable depending, for example, of where you want to deploy the application. For example, you build a Shiny application for production, and you have to think about how it will behave depending on the environments you are going to deploy. Maybe you are going to have this Shiny app for one customer, and it can be used for another customer, but on different platforms with different values, different environments. So you expect the code base to be customizable, and you also expect it to be safe to update. Something that is in production most of the time, you are going to work on it for a couple of days, months, maybe years. And at some point, you are going to deliver the product to the clients. And maybe the client is going to come back in a year and says, oh, I've been using it, it works well, but I know I need that. But if you don't have prepared your software to be easy to update and to catch any bugs that can be created by the fact of updating the code base, you're gonna have a bad time, because you can create bugs inside the code base if you haven't created this piece of software which is safe to update. And of course, finally, something that is in production. So first it's used, it's relied upon, and it has real-life impact. This is also an answer to the tweets I've shown at the beginning. Is one of the main differences is accountability. So if something goes wrong, there is someone that is going to be blamed for it. So that might be one of the things that says that something is in production. So what can go wrong? This is the scary slide. Maybe at some point the software is not available. Maybe you are making an update that breaks the code base, or you're working on the code base and suddenly the whole software breaks. Maybe you have created a piece of software, I don't know, maybe you have created a Plumber API that is used by another software in the company, in the environment, and maybe you are updating this API and suddenly the other service breaks. And something very important is that maybe at some point the results are no longer reliable. That's important because that's harder to catch. It's easy to catch that a software doesn't work, that you can't reach the application, that you can't launch the package. It's easy to catch that when you are developing it, the code base breaks, or it's easy to catch that another service breaks. But catching that your application is not giving reliable results is kind of hard, because you don't see it immediately. The software still provides results, but they are not reliable anymore. Which is kind of important also, because people using the application, the software, they are going to rely on these results to make decisions. So if at some point they are not reliable anymore, they are going to make bad decisions. So real-life impact, second scary slide. What can happen? You can lose data. Maybe the software just stopped working and erased all the data. That means that you might lose some money, and of course you might lose some time, either as a user or as a developer, because if the software is not working on a Monday morning, you are the one people are going to call just to fix it. But I don't think you've planned on working on fixing bugs on a Monday morning. So this is some time lost for the person working either with or on the software. And finally, real-life impact is making bad decisions, so for the person using the software. So just to sum up this first part, sorry if I have scared some people in the room, but I think when we are talking about production and what it means to be in production is that we are considering that something that is production ready is something we can rely on. And in the rest of this talk, I'm going to show you what you can do to build reliable tools. So, what is production? We've seen that. And now, what about R and production? So, little Q&A. How many ways do you think there are to build an R package? So we think there are 5 ways to build an R package. Who thinks there are 2 ways? Nobody? Who thinks there is just 1 way to do it? Okay, who think there are 15 ways to do it? Okay, so thing is that there are just 1 way to build an R package. How many ways do you think there are to build Node.js modules? Thousands and thousands. So why am I saying that? Is that you might think that packages are very complicated because there is this like strict structure and there is just 1 way to do it. But no, that's very good that there is just 1 way to do it. Because basically, what it means when there is just 1 way is that what do you do if you want to make an R package? You sit down, you follow the steps, you follow the documentation, you have a package that works. You don't have to improvise, you don't have to invent a new structure and think about how things work together and how are things orchestrated. There is just 1 way to build an R package, which is awesome, I think, which is really a good way. So, how to build these reliable tools? So, rely on frameworks, so packages of frameworks, like thousands of people have been working, building packages and improving packages and improving the structure, and we are all working, so all the package developers are working on a common framework with a common skeleton with like the way to do packages. Which is amazing because we have these like decade-long collective intelligence about how to build good packages in R. And you're not going to find, I don't know, if you go on Google and you type how to build a Node.js module, you are going to find thousands of blog posts with thousands of different ways to do it. If you are typing how to build an R package, you are going to find thousands of blog posts and books, but they all like give you the same information. So yeah, building an R package is following these rules that have been built for years and just like standing in the shoulder of giants, just using this common collective intelligence. And of course, that also means that you don't have to reinvent the wheel and that you shouldn't reinvent the wheel. Because I know that when we are software developers, when we are software engineers, we like coding, we like building stuff, but most of the time, if we have a question, if we have something we want to do in R, there is probably someone before you that like had the same issue or asked himself the same question. So someone somewhere in the community might already have solved the problem you are trying to solve. I mean, there are, I think, like 15,000 packages on CRAN. So there is probably the answer to your question there. If it's not, there is probably a blog post somewhere with the answer or a package on GitHub. So instead of going straight into coding algorithm and function and trying to do things, the first thing you need to do is just benchmark what exists for solving the specific problem you are trying to solve. And of course, the R community is also awesome because there are a lot of tutorials everywhere, and R packages are well documented for most of them, and the R community really emphasizes the need for good documentation. So there are good tutorials and there is good documentation most of the time for packages and tools that already exist. And of course, comment everything you are doing, test everything you are doing, and monitor anything you are doing. And what I mean by monitoring is not, so if you think about, I don't know, you are building a Shiny app and you are pushing it into production, and I'm saying, okay, you should monitor the status and you should monitor your app. What you might be thinking is just, okay, I need to create some kind of process that is going to be able to ping the application to see if it works. But it's not just that. Monitoring is also giving a space for the users to give you feedbacks about your application. For example, when you are a package developer, it's really important and is really rewarding to have something open source with an issue process, for example, with GitHub. On GitHub, people can make issues, and it's a way to monitor the health of your package because people are going to use your package, and if something fails, because there is always something that fails at some point, they can open issues and you can monitor the health of your project just by getting feedbacks from the persons that are using your package. So this is kind of nice because, the more you have issues, the more it means that you have users, but the more you have users, the more you have issues, so the more things you have to fix, and et cetera, et cetera. So, yeah. Okay, so another thing that is important really is that conventions are awesome, and so is the R community. What I mean by that is don't try to reinvent the wheel, because the R community have been building collective intelligence around building reliable tools for R. And for example, something which is pretty unique for software community is the CRAN. Do you know, for example, how many, so the equivalent of packages for Node is a module there? Does someone know how many modules for Node.js there are on NPM, so which is the CRAN version of Node? So there are 15,000 packages on CRAN. And there are more than 1 million modules on NPM. So the difference is, of course, that Node is widely used compared to R, but the difference also is that anybody can push a module on NPM. So you can I can write a Node module and push it to NPM. It's probably poor quality, but it's going to be accepted because nobody's checking the correctness of what I did. You can just push your modules. It can just be one function in it with no documentation. But on CRAN, if you want to submit something to CRAN, you have to be a little bit disciplined about what you are doing, because they are asking your package to pass a series of tests. Your package should be installable. Your package should be documented. So these conventions that can be hard to follow if you are starting a package that you want to publish on CRAN, it's actually a good thing, because the things that end up on CRAN, they are actually tested by someone. So they are not just random packages that are put there. Okay, so now let's talk a little bit about the tools that exist for building software in R. So first of all, R packages. So I've talked about packages already, but if you think about what a package is compared, for example, in the context of production, the main goal of a package is to be shared and reused. The main reason for building a package is creating code, bundling it, and making it under a format that can be shared to someone else that can install it on the machine. Which is more or less what you are doing when you are sending something to production. You are building something that you are going to share and reuse. And of course, the important thing about packages is that we have years of toolkits that have been built to build packages. So it's also something that is pretty unique for the software community, is this relentless effort from the R community to build tools that help people build tools. So this kind of meta tools. So we have years of people working on this kind of tools, and of course, a package is something that everybody knows, in the sense that this is one of the first things you learn when you are starting to use R. It's to do library package. So what are these tools for building packages? They are tools to automate and document and test. So DevTools is a package that bundles a series of other tools to build packages. And there is also the use this packages, which is literally a package that is designed to help you with the whole skeleton and the whole infrastructure of your package. And the test that package, as its name suggests, is a package for writing tests. And Oxygen 2 is a package for documentation. There is also, so this is the little self-promotion slide. If you are building Shiny apps, so we've built at ThinkR a package called Golem. If you want some X stickers, because I know you're just here for stickers, I've put some X stickers at the registration desk, or come to me, I still have some to share. That being said, Golem is a framework, so it's in the same spirit of a package, is that we want to provide a framework, a collective framework for building Shiny apps. So the good thing about Shiny is that you don't have to think a lot about the structure until it's important. But you tried to take it the other way and just bother you with the structure from the beginning, so that when you want to go one step further, you don't have to think about the structure at that point. So the idea is to provide this framework with solid ground for Shiny, a lot of automation, of course, because when you are building Shiny apps, you don't want to be copying and pasting elements, for example, Shiny modules. And we have tried to build these tools that allow you to automate the creation of files, the creation of skeletons, so that you don't have to think about it and lose time copying and pasting things. And of course, we are really trying to build collective worldwide intelligence around sending Shiny to production. So this is an open source project, and anybody can contribute. So we try to build collective intelligence around good practices for Shiny. And I'm very happy to announce that now we have released the second version of Golem, so this week. So if you want to try the new version of Golem, you can download it from CRAN. And please open issues if you find anything that doesn't work, because as I have said before, no software is bug-free, so there might be some bugs left. Of course, now you've got your package. You want to deploy it. There are also a lot of tools that are available to deploy your application into production. For example, there are the RStudio products, so Connect, Shiny Apps IO or Shiny Server that allows you to deploy your application. You can also use tools like Docker or Kubernetes that works well for Shiny Apps, for example, or add AWS. And if you are into using R in the cloud and using AWS and Docker and Google Cloud Engine, there is a nice project called CloudER that lists a series of projects around interacting with AWS and Google Cloud Engine. So finally, last part of this talk, what are the challenges of R in production? So I think that the challenges, as I said, challenges, it's not the language, it's not the tools. The two main challenges are cultural and organizational. So it's also an answer to the tweet I've quoted in the beginning, and people love building model, but they hate paying the technical debt. And of course, that makes sense, I think. I mean, we all love building proof of concepts or like prototyping stuff, but building, like turning this proof of concept into production is a lot of work, and it might not always be the fun part of building it. So I think that is something that some of you have also experienced. So you're building a little prototype for a Shiny app to your boss, to your client, and they say, wow, this is awesome. And let's take it and put it in production. Someone has already experienced that? That rings a bell? Okay. So why does this happen? This happens because the very good thing about R is that you can start using it and get results in a couple of hours. But this is also the bad thing about R, that you can start using it and get results in a couple of hours. So it's really easy, especially with Shiny, to build a prototype in Shiny. So basically, as I often say, the first step for Shiny is there, but the next step is way higher. You know, when you are starting Shiny, you can have a prototype in a matter of hours, but like jumping to the next step can be a little bit harder. And of course, R developers, most of the time they don't learn R as software engineers. So they learn R maybe in a stat course. So they learn R as a tool to do stats, but not really as a programming language. They might not know what's needed for production. That is to say that if you are showing your prototype to your boss and he says, send it to production, maybe you don't know what's needed. And finally, and this is important, IT might not be really receptive when you are showing them R code. So how do we adopt this production mindset? The first thing to think about is no more that works on my machine. You know, there is a famous code by Jenny Bryan that says, if your script starts with setWD and a relative path on your machine, I'm going to come to your office and burn your computer. That's exactly that. When you are starting to build something for production, you have to think that you are building something, a piece of software that is going to be used somewhere else. So you have to adopt a mindset in which you are not thinking about, okay, but that works on my machine. And while doing that, you are going to work in a package. So everything should be a package. Why? Because if you are building a package, everything is a package so that you can handle dependencies, you can handle documentation, you can handle all these kind of things. Because, you know, if you are giving your IT a script that starts with setWD and library something, library something, library something, they are going to call you and say, okay, I've got this setWD, what should I do? Okay, so They change something, okay, and I got library this, library that, what should I do? What does it even mean? So basically, if you give them a package that works, that install all these dependencies and has documentation and testing, you can say, okay, you have to install this package. That's it. And the package is going to take care of its dependencies and maybe system requirements, and things like that. So don't start with these kind of technical debt, or I don't have any documentation about dependencies, about things like that. And of course, IT are your friends. So I'm sorry to tell you that, but it's going to be harder to prove yourself to IT that you can put R into production. Why? Because R is not a language they are familiar with. And most of the time, if you are giving them an R product, they're like, am I responsible for this? Am I going to maintain it? So the thing is that if you are adopting all these things I've said before, and you are providing something that, like a Docker file, that they are comfortable with, and proving that you have done your best to make something which is of quality, something that works in production, it's easier there. And of course, infrastructure is very important. As I said, if you are building something for production, it's going to be like deployed and used somewhere else. So you have to think about what you are building, and if, for example, you are using special packages that need system requirements or things like that, you have to be aware of that. And of course, reliable code matters in the sense that please write comments, please adapt some kind of style when coding, just writing good code so that when you are working again on a code base, you don't have to spend, I don't know, one day just reindenting everything because you don't really understand what's happening. Okay, so how to confidently send R to production? First, just convince yourself that you can be a good software engineer. You have all the tools you need, you have all the documentation you need to become a good software engineers. And of course, the first person you have to convince that R works in production is yourself. So I hope I convinced you in this talk, and thank you.